Hello everyone, welcome to Cornell Physics. Today we are looking at scientific notation and significant figures. In the previous video, measurement and prefixes, we came across very small and very big numbers. These are tedious to write because you're writing down a lot of zeros. But not to fear, there is a better way. We'll start with the general form for scientific notation, which is over here. This looks weird and complicated, but it's really simple. So here, this letter lowercase c, so that represents the coefficient. And the coefficient is simply just a number that must be equal to or greater than 1, but less than 10. This here, 10, this is known as the base, and it's always 10. So I'll just neaten that up a bit. And finally, this lowercase p is the power, which is usually a whole number. Let's apply this to these two examples. So the first example is a large number, and this is the mass of the moon. 735 followed by 20 zeros in kilograms. So as you'd expect, it's pretty heavy. There is a lot of zeros to write, but we don't have to do that with scientific notation. So I'll start by just giving you a quick example to start us off. So you can write the number 200 like 200.0, or if you want to keep going, 200.00. I can keep adding zeros after that decimal, and it's the same number. So why do I start with that? Well, it's because you can see that there must be this invisible decimal at the very end of the mass of the moon. So now going to scientific notation, the coefficient lowercase c must be between 1 and 10. So it can be equal 1, but it has to be less than 10. So that means I'd put the decimal over here between the 7 and the 3, because that means I'll have 7.35. So let's start by writing that. 7.35. So now what comes next? Well, that's easy because it's always times 10. But now the power is decided by seeing how many times I have to move this decimal point, how many digits I have to move the decimal point till I get to the very end. And I'm not going to bore you by doing all the digits, but from that dot there, between 7 and 3, I have to go 22 times to get to the end. And because I moved to the right, that means the power is positive 22. And don't forget our units. And that's it. Let's do the example with the small number. So as an example, I've got the radius of a hydrogen atom, which is this small number here in meters. So I don't have to show an imaginary decimal here because the decimal is already there. But now I need to decide where I put the decimal to have the coefficient between 1 and 10, which would be here. Okay, so 5.3. So let's just start by writing that. 5.3 times 10. So what's the power going to be? Well, I've got to see how many times I go from that decimal I put between 5 and 3 until I get to the decimal in the original number. And because I'm moving to the left to do that, and I had to do that 11 times, my power is going to be negative 11 in meters. Now that we've done a few example problems, the question is, how do we know how many digits to use when writing our final answer? So enter significant figures. So what are significant figures? They are the digits that reflect the degree of accuracy, starting from the first non-zero digit. So here are 4 rules to decide whether zeros are significant or not in your answer, because 0 is the tricky one. Captured zeros are significant. So zeros in between two non-zero digits, in this case 8 and 3. Trailing zeros in a decimal number are significant, so zeros that come after a decimal point. Leading zeros, however, are not significant. So these are zeros before the non-zero digits when there's a decimal. And trailing zeros in an integer without a decimal point are also not significant. So in the number 600, the two zeros are not significant. Let's put these rules into practice in this example table. So with 14, no zeros, so nothing controversial there, 2 sig figs. 14.0, that's going to be 3 sig figs because that is rule number 2. The zero after the decimal is significant. 2 sig figs for 1.4, no zeros, nice and easy. 50, one significant figure because that's rule number 4. Also same deal, rule number 4 for 500. But now 5001, we've got captured zeros, so those are significant again. So that's 4 sig figs. 5010, that is 3 sig figs. That last zero is not significant. Again, rule number 4, but the captured zero there, that is significant, which is rule number 1. 50.0, all are significant there with the decimal. 1708, the zero is captured, so that's significant, 4 sig figs. Now we've got leading zeros for a decimal, so those are not significant, so that last digit there, the 1, is the only significant figure. But now we have 3 sig figs, because those trailing zeros with a decimal become significant, rule 2. And now with scientific notation, the base and the power, don't worry about positive or negative. We never consider these as part of significant figures, so we only look at the coefficient. So just treat it like it's 1.90 and 1.09 when deciding significant figures. So that would be 3 and 3. Now we'll do a couple of examples that kind of bring a few concepts together that we've covered in this video and in previous ones. So if you notice on the top here, there's the prefix table that you're going to get in assessments. And it says prefixes of the metric system. So we don't have to know what the metric system is yet. That's coming up in the next couple of videos. We just need to know how to use the prefixes as discussed in other videos. So let's convert 0.00008125 meters into micrometers and express in scientific notation to 3 significant figures. So it's a bit of a mouthful, that one, but we'll just do one thing at a time. So what we're going to do is introduce the micro prefix, which is here in our table. So it's a Greek letter, and we pronounce that as mu. So it's a lowercase mu from the Greek alphabet. And you can see the more important thing is that the multiplying factor is 10 to the negative 6. So as we have seen from before, because we are introducing the prefix, we don't multiply, we divide. So if you're not sure about this, please watch the previous video, measurement and prefixes. But we're going to divide by that factor. So 10 to the negative 6 goes there. And putting this in our calculator gives us 81.25. And that now we can write micrometers, okay, or micrometers. So that is simply from the table, the symbol for micro. But we're not there yet. We've only converted to micrometers. So we now need to make sure we write this in scientific notation. So writing in scientific notation, we make sure we put the decimal place between the 8 and the 1. Times 10 to the power of 1. And that's micrometers still. So that's because we would have to move this decimal that we've placed one place to the right. to get to the original number. So it's positive 1. And the last thing is to write this to 3 significant figures, because right now you can see it's 4, 8, 1, 2, 5, they're all significant. So we can simply use rounding to adhere to the 3 significant figures. So that digit there, the 4th digit is 5, so we can just use the common rounding method. So if the next digit is 5 or more, then you can just round 1 digit up. And that's example 1. Example 2. Convert 703 gigameters into meters and express in scientific notation to 2 significant figures. So now we're doing the opposite. We are rewriting it so that there is no prefix. So this time we do indeed multiply by the factor. So first of all, let's find giga in the table. So capital G, you can see that there. You can see over here the capital G in the example, and that corresponding factor is 10 to the 9. So writing 703, but instead of giga, we write times 10 to the power of 9. Still write your units, meters. I guess I should write meters up here as well for that. And that is the converting to meters done. So now we will express this in scientific notation. So it might look like it's in scientific notation. It's not far off, but we need to make sure that coefficient is under 10, but above 1. So we can write that as 7.03, just putting the decimal between the 7 and the 0. And that would become times 10 to the power of 11, because you would have to move this decimal 2 places to the right to get to the original 703. And don't forget our meters. And the last thing is to make sure we convert to, write our answer in 2 significant figures. So since this is the 3rd digit, we want to round that one, but it's under 5, so we can just leave 0 as is, times 10 to the 11 meters. So now we've done everything in the question, and that's it. One thing I should clarify is the reason that this power is 11 is because from our prefix giga, this is 10 to the 9. So by moving that decimal from the end of 703 back another 2 places to 7.03, that means we would have to move an extra 2 places to the right to get the full number. Thank you for watching this video. If you found it helpful, please like and share it, and subscribe to my channel for more.